All right, so today is the first day we are getting into quadratic functions. And so the first thing we need to talk about is some vocabulary. And so get some colors because it's going to look a lot better if you have everything color coded. And so first of all, a quadratic function we talked about at the very beginning of the year is any function that has an x squared. Okay, so when you see the 2 right here, this squared, it makes a U shape. This U shape is called a parabola. Okay, so when you see that word parabola, it just refers to the U shape that this graph is making. We have talked about the linear functions extensively, and we have also talked about exponential functions where x is in the exponent. And so as a quick review, let's talk about the parent function y equals x. That's the linear parent function. And so the linear parent function has a slope of 1 and a y-intercept of 0, and it makes a line. Okay, and the domain and range were both all real numbers, because it goes forever to the right, forever to the left, forever up, forever down. So this fancy R with 2 lines is all real numbers. Okay, the next function we talked about was the exponential parent function. Okay, exponential. And we know it's exponential because x is in the exponent. And so that had a horizontal asymptote. I'm going to label that asymptote at y equals 0. And it had a y-intercept, and it was growing exponentially. So it made this curve, this L-looking shape. Okay, the domain of exponential functions was all real numbers all the time, never had to think about that. And then the range was y is greater than 0. Okay, don't put a line underneath that greater than sign because you never actually equal this asymptote. The function gets really, really, really close to it to where it looks like it's a flat line, but it never actually touches it, so we don't put the line underneath. Okay, the last function we're going to talk about this school year is the quadratic parent function. And so remember, the 2 makes a U called a parabola. Okay, so we have a parabola, we have a line, and then for the exponential graph, we just kind of call that a curve. We can call it a growth curve as opposed to a decay curve. And so for the parabola, the domain is also all real numbers. So for all 3 of our parent functions, the linear parent function, the quadratic, and the exponential, all of them always have a domain of all real numbers. The range is what changes. The range for the line is all real numbers, but for the exponential, it's y is strictly greater than 0. For the quadratic, it's greater than or equal to this minimum point right here called the vertex, which we will label up here. And so the range is greater than or equal to 0. So for quadratic functions, we will always have the line underneath. For exponential functions, we will never have the line. Okay, and so that's the biggest difference between these 2. All right, so let's get into some more vocabulary about the parabola, the quadratic function. Some of this we've already talked about, so let's start with these 2 points right here. These are the x-intercepts. We've talked about x-intercepts since day 1. Okay, it's where it crosses the x-axis. And so these are ordered pairs. It looks like we have one at -2, and the other is at -6. So -2, 0, and negative 6, 0. Those are our x-intercepts. You have to be careful with x-intercepts because they have 4 different names. Okay, and so here's your acronym for this. ROCKS. Okay, they are called roots. They are called, this stands for zeros. We've talked about zeros. And then, of course, x-intercepts. And the 4th name is solutions. Solutions. Okay, so roots, zeros, x-intercepts, solutions. 4 different names for these points right here. So if a test question asks you for the x-intercepts, and then asks you for the roots, and then asks you for the zeros, or then asks you for the solutions, all of those are referring to these 2 points right here. Okay, 4 names for the same thing. Okay, the other thing that we have talked about is the y-intercept. Okay, and so this point right here is called the y-intercept. All functions have an x-intercept and a y-intercept that you can refer to. Okay, and so the y-intercept is at 12, and so as an ordered pair, the x is 0, the y is 12. No other special name for y-intercepts. You can't call this one a 0. Zeros only refer to x-intercepts, and a lot of people get confused by that. Zeros only refer to x-intercepts when the y is 0. Okay, so some new vocabulary is this point right here called the vertex. Okay, and in this case, it is a minimum. Okay, the vertex is always going to be a max or a minimum. Max or minimum. Sometimes this quadratic will be upside down. And so in this case, the vertex would be the maximum. I'm just going to say max. Okay, vertex is max, depending on which way the parabola is facing. And there's actually a way to tell which way the parabola is facing by just looking at the equation in its standard form. Standard form for a quadratic is going to have ax squared plus bx plus c, where a, b, and c, a, b, and c are just constants, just random numbers. And so we'll look at lots of examples. Okay, the other new vocabulary is going to be this vertical line right here called the axis of symmetry. We abbreviate that AOS. So if you see AOS, it's referring to the axis of symmetry. And it's a vertical line, so we know it has an x equals equation, and in this case, it's x equals -4. Okay, if you put y equals, it's wrong, so be careful. Here we have a horizontal asymptote, that's y equals. Here we have an axis of symmetry. And what that means is if you draw this line, the function looks exactly the same on each side. It's like a mirror, okay? That's why it's called an axis of symmetry. And the axis of symmetry always goes through the vertex. And so some key things you want to remember is always vertical. And so it has an x equals equation. The other thing you want to remember is that it always goes through vertex. Through vertex. And so for this, the ordered pair for the vertex, it's a point, -4, comma, and then the y value is also -4. And hopefully these are showing up better on your copies. My copy is kind of bad. So -4, -4. And so it is always going to have the same x-coordinate as the vertex. And so if you know the vertex, you know the axis of symmetry, and we're going to talk about that a lot throughout this unit as well. Okay, so that's the key attributes of our quadratic function, and we're going to go in depth into each of them. So axis of symmetry, this vertical line right through the middle, the vertex, which is a max or min, depending on which way your parabola is facing. We have our x-intercepts, which has 4 different names: roots, zeros, x-intercepts, and solutions, and then our y-intercept.